So, just getting into the peptides themselves here, can you just define peptide for the audience? What exactly is a peptide?
Yeah, absolutely. So when we think about a peptide, I like to make things really simple. So if you can imagine, we've got two amino acids over here. It doesn't matter which ones. And let's say there's a peptide bond in between them. So now they're joined together. And what we have is a peptide. And when we think about different peptides in the body, if they're 2 to 4 amino acids long, these are going to be bioregulator peptides. And it kind of makes sense if we think about how small 2 to 4 amino acids would be, that they can kind of sneak in and make epigenetic changes. So sort of rewire our DNA to how it's supposed to be. And most of those are going to be things that are going to work on specific organs or systems. So for instance, like there's a kidney bioregulator, a heart bioregulator, those sorts of things. Now, when that chain gets a little bit longer, up to 45 amino acids, that's standard definition of a peptide. And some simple ones, just to kind of give some context for people. Everybody probably has seen the Ozempic, but that's a semaglutide, which is going to be peptide, and BPC-157, 15 amino acids long, um, thymosin beta 4. All these essentially are going to be under that 45 amino acid mark. And the way these peptides work is they send signals. They talk to our cells. So it's kind of like they go over, they tap the cell on the shoulder in the case of like semaglutide, and they say, hey, after we eat that meal, we want to regulate our blood sugars a little bit better. So I need you to do this, this, and this. So just kind of like a supervisor.